Okay, these are the Module 5 notes. Examine relationships and linear regressions. Now, long set of notes, lots of stuff to read through in the first half or so. Some things I want to highlight, hopefully to help some things make sense for you here. So we're starting with two graphs. Top graph is COVID-19 cases per GDP per capita. Okay. Notice here, as the GDP goes up, and love this graph with all the little flags in there so we know which countries we're talking about. But as the GDP goes up per capita, our COVID-19 cases per 100,000 people go up. Okay, a couple things I want to point out. We have a label at the top, a title that tells us what the graph is. Both of our axes are labeled, and they're very fairly specific labels. So we know exactly what we're talking about. So here, and I'm just going to answer that first question up here, as GDP per capita, and of course that's in dollars, capita. Goes up. Then COVID-19 cases. Per 100,000 goes up. Notice we have the dotted line in there. That is going to give us a trend line or a line of best fit. Notice that not all data points lie on that line. Actually, most of them do not. But it gives us a relationship that the two variables are following. Okay. Bottom graph. We have got COVID-19 cases by median income. This is a nice one because we've also color-coded median incomes in the 5 boroughs of New York. Notice here, as median income goes up, the number of COVID-19 cases per 100,000 goes down. Again, we've got that line. If we take a look at all our data, it trends down. The majority of these points do not lie on that line, but that line is going to give us a way to predict our response variable based on our explanatory variable. Okay, so yeah, we've answered both of those questions. We are going to start by creating scatter diagrams or data clouds. You may be used to calling them scatter plots. And used to spending the time graphing them by hand. We are not going to graph by hand. We are going to use technology. Excel will do this for us, but we're going to tend towards Desmos because this is really straightforward in Desmos. We're going to use it both here. As we complete these notes, you will use it for your project. And you should see descriptors of the steps you need to follow to crank that information out. And Desmos is just a little easier than Excel when it comes to lines of best fit and scatter plots. Okay, so we've got situations here. Notice that our first graph, top left, kind of looks like our graph up top. as our explanatory variable increases, our response variable also increases. And so our explanatory always goes down here on the x-axis, our response up here on the y-axis. Okay, so this top left graph, we have got a positive relationship. Think about what you remember about the slope of a line. This line goes up to the right, positive slope, positive relationship, and it looks like this data is going to be described fairly accurately using a straight line model. Okay, top right, we've got, again, a linear relationship, but this time it's negative. If we draw the line that goes through our data set, we notice it goes down to the right, so we have got a negative slope on that line. Look at the bottom left. It looks like there is a pattern, and I can draw in a curve that matches that pattern. It's definitely not a straight line, so it is possible to have a relationship that is there but is not linear. Okay, that is different than the bottom right graph where there is no relationship. Okay, so make sure you can differentiate between a relationship that is not linear versus a relationship that is not there. There is no relationship. Two different things. Okay, when we look through this, we are talking about what we call bivariate data. Bi meaning two, variate means it varies. So we are looking at two variables. We will always have pairs of numbers that go together. Okay. Our input, let's make this a little bigger, is our explanatory variable that always goes on our x-axis. And then we have our response variable. That's our output. It goes on the y. Okay. These are defined here below. So you can read through that, hit pause. I won't take offense. And let's take a look at example 1. We want to see whether the score a student receives on a test is affected by how much they studied beforehand. What's the explanatory and what's the response? So our explanatory is how much the student studied. If you want to think of it in terms of time, that has to happen first, right? Our response variable then is going to be the score they receive on the test.